This is Algebra 1, spring test number 15, be our study guide. We're going to eliminate question number 3, not because it's exceptionally difficult, but because it has h to the fourth in it. We didn't go over how to undo variables or how to do variables when they were under a radical. So we'll just take it off for right now, talk about it after this test. Number 1, 4 times the square root of 180. That's not a perfect square, 180. So what we need to do is we need to come up with a perfect square that goes into it. Now, we know 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. Those numbers keep going. What you want to do is you want to find the number that goes into that. Now, the best number to use is 36, but you might not know to multiply 36 by something. So if you ask yourself the 3 questions we went over this week, remember you have to get no for all 3 of the questions. If you ever get yes, you have to simplify it again. Just do the same step again. Just don't forget to bring everything down. Remember, the 3 questions we talked about were, are there any perfect square factors under the radical? Is there a large radical with a fraction underneath it? And is there a radical at the bottom or the denominator of the fraction? Remember, if any of those are yes, you have to continue to simplify it. It's not good enough. That being said, though, just for the sake of time, to simplify this one, we're going to use the square root of 36. It's the best one to use. You could have used 16, or you could use 4 as well. 36 multiplies by 5 to give 180. What you can't forget, though, is you can't forget to bring this 4 down in front of it. 4 is multiplying by it. So the square root of 36, we're all pretty good with that. We know that that's the number 6. It's not 6 times 6. It's not the square root of 6. It's simply 6. So 4 times 6 times the square root of 5. And when you put 4 times 6 together, you know you get 24 times the square root of 5. Again, the same 3 questions you ask yourself. Is there a perfect factor in the square root of 5? And remember, these are your perfect square factors over here, these numbers. And they continue to go past 6 times 6. No is the answer to that. The second question, is there a large radical with a fraction underneath it? No, there is the answer to that. And the third question, is there a radical at the bottom of a fraction? No to that one as well. So since that all those answers are no, this is your simplified version for number 1. The square root of 128. Again, go through your numbers. The number 4 goes into it as for sure. Let me show you what happens if you don't use the biggest number or the best number right away. The square root of 4 multiplies by something to get 128. You know 4 times 3 is 12, and 4 times 2 is 8. So when we simplify this, the square root of 4 we know is 2 times the square root of 32. Okay, here's where you ask yourself the 3 questions. The first one, is there a perfect square factor in 32? Remember, these are your perfect square factors, and they continue past 6 times 6. Sure, we know the number 4 goes into 32, but even better, the number 16 goes into 32. 16 multiplies by 2. What you can't forget, though, like I said, is to bring that 2 down. That'll be the mistake people make once they start getting good at this. They'll just leave a number and forget to bring it down. So 2 multiplies by the square root of 16, again, which is 4. Remember, it's not 4 times 4. It's not the square root of 4. It's simply 4 times the square root of 2. And when you put 2 times 4 together, you get 8 times the square root of 2. Ask yourself the same 3 questions again, just to make sure it's simplified. Is there a perfect factor in 2? No, because all the numbers are bigger than 2. Is there a large radical with a fraction underneath it? No. And is there a fraction with a radical at the bottom? No. No, no, and no means this is simplified. Number 4 acts just like last night's homework problem number 21. If you separate it and make it the square root of 450 over the square root of 6, you're left with something that doesn't have a perfect radical at the bottom. We have not learned how to rationalize this and multiply it by whatever's on the bottom. So the alternative, the way you work this, is to simply divide 450 by 6. When you divide 450 by 6, you get the square root of 75. And that's a whole lot easier. We know that the perfect factor of 75 is 25. So the square root of 25 multiplies, think about 75 cents, 3/4. So set 25 times 3. The square root of 25 is 5 times the square root of 3. Same three questions. Is there a perfect radical in 3? No. Is there a large radical with a fraction underneath it? No. Is there a fraction with a radical at the bottom? No. No, no, and no means these three problems are simplified. Any Number 5 and 6 tell you to solve the equation using square roots. Remember what your order of operations says. Your order of operations says parentheses, exponents, which we added radicals to that step. They go together priority-wise. Multiplication, division, addition, subtraction. That's when there's no equal signs involved, or that's when you're not dealing with an equal sign and you're just simplifying it. Anytime you're dealing with an equal sign and you are trying to undo it, you take this entire thing right here. You take this entire thing and you do it in reverse. Okay, so you do any addition and subtraction first, then you do multiplication and division, then you do exponents and radicals, then you follow it up with parentheses. So first we have something, we're trying to get x equaled all by itself. So there is minus 27 going on. You know how to undo minus 27. You add 27. You know if you do something to one side, you do the exact same thing to the other side. So 0 plus 27 is going to be the number 27. Now we have 3x squared. Minus 27 is canceled out because it's on the right-hand side. It says equals 27. So as we're looking at it now, it says 3 times x squared. It doesn't say plus or minus anything, so we're finished with the addition and subtraction step. The next step is anything multiplying or dividing. It says 3 times x squared. Undo 3 times something by dividing. You know if you divide one side, you do the other side exactly the same. So now we have something that cancels out that says x squared is equal to 27 divided by 3 is the number 9. So now as you're looking at it, it says x squared. It doesn't say anything times x. So your multiplication and division step is done. Now you're on to your exponents / radical step. It doesn't say x by itself. It says x squared. So we know to undo x squared by taking the square root of it. If you take the square root, that's the inverse operation. Again, whatever you do to one side, you do to the other side. That will cancel out x squared and leave you with x. And the square root of 9 is 3. Both positive and negative. Remember, there's a negative to go along with the principal square root. But those are your steps for solving using square roots. You're going to do the same thing with number 6. You're going to work that order of operations backwards. Undo plus 20 by subtracting it on both sides. 4 minus 20 is equal to negative 16. So you have something that says x squared equals negative 16. Undo x squared by taking the square root. If you do it to the left, do it to the right. Now you have something that says x equals the square root of a negative value. Remember, it does not matter what that negative value is. You should be thinking of number 4. But 4 times 4 gives you positive 16, and negative 4 times negative 4 gives you positive 16. There is no real number that gets you to the number negative 16 when you multiply it by itself. So x is no real solution. Number 7 says to solve this one by factoring. Remember, factoring means take a trinomial like z squared plus 3z minus 10 and separate it into 2 binomials. In order to get z squared, you need to multiply z times z. That gives you z squared. After that, remember, take whatever your c factor is or whatever your c term is and factor it out. 1 multiplies by 10 to give you 10. And 2 multiplies by 5 to give you 10. 3 doesn't multiply by anything, neither does 4, and then you're back to the number 5. So those are your only pairs of factors of 10. Once you have those pairs, look at your b value, 3. Which one of those pairs, 1 and 10 or 2 and 5, will get you to the number 3? Remember, the way we determine that is we combine them in every possible way. If you combine 1 and 10, you're going to get a number 9, or you're going to get a number 11. That's the only two numbers that pair will give you. So 1 and 10 won't work because that's not the number 3. If you combine 2 and 5, you're going to get the number 7, or you're going to get the number 3. So 3 is the number we're looking for. So the numbers we're going to use are 2 and 5. So now we have Z and 2 on one of them, and we got Z and 5 on the other one. We have to determine from there which signs to put. Once you know what your numbers are, look in front of your C value for the sign. Remember, that sign tells you that you're either going to have the same sign or different signs. If it's negative, like this one, remember they're going to be different. If it's positive, like this one's not, they're going to be the same. Again, since it's negative, they're different. Since we know they're different, then you look in front of B's value, and it tells you the sign of whatever number's bigger. You have two numbers, 2 and 5. 5 is bigger or larger. That said, the larger number is plus, so you're putting a plus in front of 5, and you're putting a minus in front of 2. So now you have two binomials, Z minus 2 times Z plus 5. But it tells you to solve that by factoring, so that equals 0. So one of those binomials has to be equal to 0. We're going to go ahead and set both of them equal to 0. Z minus 2 equals 0, and Z plus 5 is equal to 0. Now it just becomes two very simple equations. Undo the minus 2 by adding it to both sides. 0 plus 2, Z's value is 2. And undo plus 5 by subtracting it on both sides. 0 minus 5 is negative 5. So your two values for this one are both 2 and negative 5. Number 8 tells you to simplify the difference. Remember, you can only add and subtract things that have the exact same variable with the exact same exponent. Now, all these deal with the variable w, so you're not doing with different values, different variables, but they do have different exponents. So right here, the first one is 3w squared minus 5w squared. They have the exact same exponent, so we can take 3 and subtract 5 from it. When you do that, you get negative 2w squared. Notice we don't change w squared. We leave it just like it is. You go to the next biggest degree. Remember, you always go to the largest degree and you count down. Negative 8w to the first power minus 3w to the first power. So negative 8 minus 3. If you have to, think of where you are on the number line. You're at negative 8 and you're subtracting 3 more, which means you're going to the left. So negative 8, 9, 10, 11 is negative 11 w to the first power. Then you go to the constant term that doesn't have a variable. Negative 7 minus a negative 4. Remember, anytime you have minus a negative something, like negative 7 minus a negative 4, minus a negative means to add a positive. So negative 7 plus 4 is going to be negative 3. And here's your trinomial when you simplify it by subtracting the 2. Simplifying the product for 9 and 10, multiply the coefficients. Multiply 8 times 6 to get 48. Multiply 8 times 6, the same one, to get 48. And it's positive, that's why I put a plus in front of it. Then multiply the variables. X to the 5th times x to the 7th. Remember, anytime you multiply the same bases in variables, x to the 5th times x to the 7th, it tells you to add the exponents. So x to the 5 plus 7. So we get 48x, 5 plus 7 is 12. Also multiply x to the 5th times y to the 6th. Now, those are not the same variables, but they're still there. So it becomes x to the 5th, y to the 6th. You do not add 5 plus 6 right there because they are not the same variables. So this is your This is distributing 8x to the fifth to both of those terms. We're going to do the same thing with number 10. 8 times 5 is 40. 8 times negative 6 is negative 48. Do the same thing with the variables. A to the 7th times a to the 5th. You add 7 plus 5 and you get a to the 12th. A to the 7th times b to the 4th. You don't add those because they're different. You still represent a to the 7th, b to the 4th. And here is your binomial. Number 11 says to write it in standard form. Remember, standard form means tells you to put the largest exponent first and count down, or the largest degree first and count down. This is your largest degree, g to the third. You put the whole term, negative 2g to the third. The next largest degree is g to the second power, this one. You put the whole term again, plus 3g to the second power. The next biggest term is g to the first power, this one. It's positive, there's no sign in front of it, but you know it's positive, so you put plus for positive for g to the first power. And finish it off with the constant term that doesn't have a variable, negative 7. That's standard form, from largest degree to smallest degree. Simplify the sum for number 12 is just like simplify the difference a few minutes ago, except you're adding them. You only add the ones that have the exact same variable to the exact same exponent. 3u to the third plus 6u to the third. 3 plus 6 is 9u to the third. The next u exponent is 8u squared. Notice there isn't one on the right. There's only an 8u squared on the left. So we put plus whatever it is. In this case, 8u squared. The next biggest exponent is u to the first power. There's only one of those. So we put plus a negative 7u, which means minus 7u. And you finish it off with the constant term, 7 plus 4. There are two of those. And 7 plus 4 is a positive 11. That's adding the polynomials.